Here we're asked to solve the union of two inequalities, not the intersection, not an upside down cup or the word and. No, we have a U and the word or. You can have either of those there, and that either of those represents the union of all the solutions to the inequality on the left and all the solutions to the inequality on the right. So we have on the left 4 minus 3x is less than negative 2, and on the right we have 3 parentheses x minus 2 is less than or equal to negative 6. Okay, let's work on the first inequality. We'll isolate the x term and put the union symbol down, and let's work on the right problem. We're going to eliminate the parentheses by distributing the multiplication. 3 times x is 3x. 3 times negative 2 is negative 6. Bring down the inequality sign, less than negative 6. Okay, back to the right side. Let's get the x alone by dividing both sides by the coefficient. The coefficient of x is negative 3, so we divide both sides by negative 3. Now watch out, we have to flip the inequality. See, the alarm should go off in your head. We flipped the inequality because we just divided by a negative number. Okay, so we flipped our inequality sign. Over on the right, union this together with isolating the x term. We're going to add 6 to both sides. 3x is less than or equal to 0. Okay, so bring down the simplified left side. We have x greater than positive 2, because a negative 6 divided by a negative 3 is positive 2. Union that together with x is less than or equal to 0, because when you divide both sides by the coefficient 3, you get 0 on the right. Okay, so we're ready to take these two solutions and stack number lines and take the union. Now remember, to be in the union, all you have to do is you take two sets of numbers. The union of those two numbers includes all the values of numbers that live in just one of those sets. It does not have to live in both of them like an intersection. It lives in one of the sets or the other. It could live in both of them. That's overkill. That's more than we need. But it has to live in at least one of the sets to be included in the union. So on the first number line, we will represent the x values greater than 2. On the union that together with the x values less than or equal to 0, and that will equal the final line, which is the union of those two sets. Now let's put the pertinent numbers here. We have a 2 and a 0. The smallest one is 0, so put the 0 first and stack them up. Put the 2 and stack those up. Okay, now let's graph the first set of numbers on the top. X is greater than 2. We're just going to shade everything greater than 2 and put a round bracket because there's no equal portion in the inequality. All right, next we're going to shade on the second number line. X is less than or equal to 0. Shade everything smaller than 0 and put a boxy bracket because there is an equal portion in the inequality. Now let's consider the union on the last line. We look at the region for all x values smaller than 0. We have none of those values in the first line on the first inequality, but we do include the values in the second inequality. The second line has shading for values less than 0. Now that's enough to get it into the union. Go ahead and shade all the values less than 0. And I went ahead and put the boxy bracket. Now, should I have done that? Think about it. Should I have put a boxy bracket on 0? Well, let's see. Is 0 going to be in the union? Well, to be in the union, you only have to live in one of the two sets. 0 does not live in the first set, but it surely lives in the second set because it has a boxy bracket due to the equal portion in the inequality. So yes, it's going to be in the union. That's why it's a boxy bracket on 0. Look at the region now between 0 and 2. There's nothing happening upstairs in the top inequality or the second inequality. Therefore, it's impossible to include these values of x in the union. It's empty. Now look at the region to the right of 2. Yes, we have shading in the first inequality, and are we including the 2 in that situation? No, that's a round bracket. X greater than 2 does not include the 2. There's a round bracket on that 2, but there definitely is inclusion of the values greater than 2. In the second inequality, x less than or equal to 0, no shading happening after the number 2. So therefore, in the union, yes, we will include the shading because to be in the union, you just need to live in one of the two sets. And we exclude the number 2 with a round bracket, and that reason is because 2 does not live in the middle number line, it's empty, and it does not live in the top number line because there's a round bracket, so it's not going to live in the union. So there's a picture. It's a split interval, you see. That's our graph. If we needed to write that in set notation, we would write curly set bracket, all real numbers x, such that now we'll have to express the first shading region such that, let's see, x is less than or equal to 0. That describes the first inequality shading. And then union that together with the u. Now describe the second shading. That's x greater than 2. X greater than 2, curly set bracket. And then in interval notation, we have to express the two shadings in interval form. For the left interval, we'll have the smallest value is negative infinity, and the largest value is 0. And we get an open bracket on the infinity and a boxy bracket on 0 because it is included in the graph. We'll union that answer together with the other interval for values greater than 2. So we're going to have 2, but we're not including 2. There's no boxy bracket on 2, so put a round bracket on 2, comma, all the way out to infinity, which always gets a round bracket. And when you look at the graph, it becomes clear that this is called one of those split inequalities because it has a big gap in the middle.